Okay, I'm going to do a quick recording here on linear regression, both in your calculator and using a tool on the internet. So linear regression, what we are looking at is both the correlation coefficient and the linear regression line. So basically what this is if I were to take this line here, and let's see if I can use a line tool. Go here. Oh, I need to flip that. There we go. Hold on. Okay, so let's say I were to graph these points, and I'm graphing them and I make a nice little scatter plot. Okay, and they go like this. Okay, you get the drift. What I'm looking for is this. Okay, how linear are these lines? Okay, so is it straight like this? Is it more like that? Does it form a line that goes this way? Maybe. Things like that. So we're looking at how does that line work? The correlation coefficient is basically the sum, okay, of the difference between two pairs here. So we're looking for correlation. And it's basically, do they correlate with each other? That's all it's telling you. So is there a cause and effect relationship? The closer the correlation coefficient is to 1, the stronger the correlation is. Okay, and the correlation coefficient is between 0 and 1. Okay, with 0 being absolutely no correlation, they have nothing to do with each other, and 1 being a very, very strong correlation. And then linear regression line is basically going to be the equation of this line right here. So that's what we're looking at. Okay, so let's say we want to find the correlation coefficient and linear regression for two pairs of this data. So let's pick weight and height. So I'm going to pull up my calculator, and I'm going to put these into our lists. So I'm going to go to Stat, Edit, and I'm going to enter these values in. Okay, so my weight is entered. Now I'm going to scroll over to L2, and I'm going to enter my height. Okay, so those are entered. So now what I'm going to do is I'm going to go back to my home screen, second quit. Okay, and I am going to find the correlation. So I'm going to go to Stat, over to Calc, and right here, number 4, linear regression, AX plus B. So I'm going to enter that. I want the linear regression of weight and height. So weight was in L1, so I'm going to go second L1, comma, second L2. Okay, there is my linear regression line. So what this is telling me is that the line, the MX plus B line is of this, it's got a slope of 0.121 with a y-intercept of 50.5. Okay, so y equals 0.121x plus, I think that was 50.5. Okay, where the x, okay, I put the x first. The x is my weight, my height is my y. So this is weight and this is my height. So theoretically here, with this linear regression line, I can put any weight in for x and it would give me the height. So I'm going to get to that in just a second, but I need to find the correlation coefficient. So you can actually do this on your calculator, you just have to turn it on. So I need to come here to this catalog. So I'm going to go to second 0 to catalog, and I need to turn my diagnostics on. So I need the D, and this is already in alpha mode. So I'm just going to hit this X to the -1 button, and then to give me the Ds. And then I'm going to scroll down to diagnostic on and hit enter, and then enter again. Okay, my diagnostics are on. Now I'm going to pull that same calculation. So I'm going to go to Stat, Calc, and then Linear Regression, second L1, comma, second L2. Okay, now I'm getting that correlation coefficient, and that's my R. So 0.746 is my correlation coefficient. Okay, so that's how strong the correlation is. That's a pretty strong correlation. The closer this value is to 1, the stronger the correlation is. So there's a pretty strong correlation between weight and height. Okay, then the very last thing we want to do is say, okay, what if someone has a weight of, let's see, what don't we have on here? Let's go with like 135 pounds. Okay, what is their height? You can use this equation here to predict their height. So you would go 0.121 times that weight of, oops, I put 212, sorry. 121, there we go. Times that weight of, what did I do, 135? Yeah, 135 plus 50.5. So 66.84. So around, what is that, 5 feet, 6 inches. Okay, now you can also do this on your computer if you do not have the TI calculator. Okay, so I pulled up 2 websites, but if you just go into, Google, okay, and you type linear regression calculator, you should pull up a couple of results here. So I pulled up this second one, and then there was like the 4th one down, Desmos, which I really like. So I'm gonna go to that one first, and I'm gonna type these data values in. So I'm just gonna click on here, and I'm gonna type the weight in again. Typing the weight into X. Okay, and now I need to get rid of these rest of these values here. So I'm just gonna delete. Okay, notice I'm not seeing them because this only goes up to 16. So if I scroll out, I can start seeing my values. Okay, now let me delete the rest of the Y's here. Make sure there's nothing else. Okay, so now I'm going to put my Y values in. So I've got my height, 72.25, and it's going to start graphing it. So you can actually see the line here. Okay, so this is typed in. Let me zoom in a little bit so you can sort of see it. So if you see here, here is that linear regression line, and it's graphed for you. And if you just scroll down here, there is your statistics. Okay, so you have the M, so it's giving you the Y equals MX plus B. M is 0.121, the B is 50.5. Okay, our R is going to be 0.746. We're not going to worry about the R squared for now. You can do the same thing if you click on the quick linear regression calculator. I just like the Desmos one because it shows you, but this is the same thing, typing it in. Okay, and then our Y values. Oops, I think I skipped one. Let me see here, because they've got to line up. So 72.25. Yep, I skipped one right here. 67.7. Okay, so I type everything in, make sure they're typed in, and then calculate linear regression. There's your line. Okay, you've got your, here, so sum of X, everything here. Here's the line. Whoop. Scroll all the way down. Y hat equals 0.121 plus 50.5. And is it going to give us our correlation coefficient? Let's see here. So this one might not